Hi there. Today we're going to look at star classification, stellar classification, how we classify stars. Now, stars are generally described using the Morgan-Keenan or MK system, which is used in modern astronomy to classify stars according to their spectral type and their luminosity class. And it's named after William Wilson Morgan and Philip C. Keenan, who introduced it in 1943. It improved upon the original Harvard system designed by Annie Jump Cannon back in around 1924, which categorised stars as O, B, A, F, G, K, M, depending on their mass and temperature. The various mnemonics have been devised to help remember that order. The original one's a bit sexist in today's world. Oh, be a fine guy or girl, kiss me right now. So I prefer the out beyond Andromeda, fiery gases kindle many radiant new stars. Stars classified in the O group are the most massive and the hottest, with temperatures exceeding 30,000 degrees C, while those in the M group are the smallest and the coolest, with temperatures less than 3,000 C. Stars of different temperatures, of course, appear to shine with different colours. This is similar to what happens when you heat up a rod of metal. After heating the metal for a while, it will start to glow red. As it gets hotter, the red turns to yellow, and then white, and eventually bright blue. The same way it turns out that blue stars are really hot and classified as O-type stars, whereas cooler red stars are placed in the M class. There are other types beyond the original OBA FGKM. Q example is for a nova, W is for a Wolf Rayet star, but they're not encountered frequently and we're not including those today. Let's look at our Sun. We think of it as yellow. Therefore, it's not surprising to discover it's classed as a G star, with a temperature of around 5,500 degrees C on its surface. The table you can see lists the different stars according to their temperatures and colours. But stars can be more accurately categorised under this system by the addition of the number 0 to 9. Beginning with a 0 is the hottest and 9 is the coolest. So, for example, a G2 star is hotter than a G7 star, but cooler than a G0 star. Similarly, a B9 is cooler than a B4. In the MK system, a luminosity class is added to the spectral class using Roman numerals. Based on the width of certain absorption lines in the star spectrum, have a look at our video on the electromagnetic spectrum for more details on that. And this varies greatly with the density in the atmosphere, so distinguishes giant stars from dwarfs. Luminosity class 0 is used for hypergiants. Class 1 for supergiants, 2 for bright giants, 3 for regular giants, 4 for subgiants, 5 for main sequence stars such as our Sun, Class 6 for subdwarfs, and Class 7 for white dwarfs. Sometimes those last two classes, 6 can be classed as SD, and 7 can be classed as D. So the full spectral class of our star is a G25, indicating a main sequence star with a surface temperature, as we say, around 5,500 degrees C, 5,800 degrees K. The HR diagram, devised by Henry Hertzsprung and Henry Norris Russell, otherwise known as the hertzsprung-russell diagram, simply puts all this information into a graphical format. And whilst it can be confusing at first, it's actually quite easy to understand when you understand where the information comes from, which I hope you do now. We can see on the diagram the line that runs from the top left down to the bottom right. This is what we call the main sequence line. And most of the stars, irrespective of their spectral class, are in the main sequence on that line. Down below to the bottom left, we have the white dwarf stars. And in the top right, we have the supergiants, the red giants, and so on. So it isn't that hard. Luminosity scale is on the right, the surface temperature in Kelvin is along the bottom, and the absolute magnitude is up on the left-hand side. And if you want to look at magnitude, we have another video on stellar magnitude as well. There are a few other methods of classification, such as the Secchi classes, the Draper system, an earlier Harvard system, and the Mount Wilson classes. But none of these are as all-encompassing as the MK and the HR systems. Well, I hope you enjoyed that little look at how we classify stars, and maybe understand a little more when you read about, say, a G2V star or so on. Well, clear nights, happy stargazing, and see you next time. Thank you. And please remember, do subscribe. Subscribers mean an awful lot to me. It shows that people are interested in what I am doing.